Alright, so hi and Assalamualaikum. My name is Muhammad Safiq Ahmed AZIZUL. So I will be present about the relationship between days and number of COVID-19 active cases in Malaysia. So we are a group of 4 presenters, which is the first one is me, Muhammad Safiq Ahmed AZIZUL. The second one is AIMAN SYAZWAN bin AHMAD. The third one is Nick Muhammad WAZIEN NUAIM bin WANDY. And the last one is Muhammad FIKRI ADLI bin JAFREE. Alright, so for introduction, coronavirus disease COVID-19 is an infectious disease caused by the SARS-CoV-2 virus. Most patients is infected with the virus will have mild to severe respiratory sickness and will recover without needing any specific therapy. Some, tough, will become very ill and require medical attention. People over the age of 65, as well as those with underlying medical disorders such as cardiovascular disease, diabetes, chronic respiratory disease, or cancer, are at a higher risk of developing serious illness. Anyone of any age can become very ill or die as a result of COVID-19. Alright, the data set above is a data set of active cases of COVID-19. There are 10 sets of points that were chosen for 10 days by date 21 March 2020 until 30 March 2020. There are two variables which are days as an independent variable x, while number of active cases as a dependent variable y. It is shown that 1065 cases for day 1, 1157 for day 2, 1345 for day 3, 1426 for day 4, 1578 for day 5, 1793 for day 6, 1876 for day 7, 1973 for day 8, 2048 for day 9, and 2110 for day 10. The total of cases for 10 days is 16371 cases.
So now I'll be presenting the mathematical model, which is linear model y equal to a plus bx. The data generates a system of linear equation with the matrix representation as below. Set up the matrix for m with a dimension of 10 by 2 and y with dimension of 10 by 1. Then we need to multiply the transpose of matrix M with matrix Y. Noted that the transpose of matrix M has dimension 2 by 10 and matrix Y has dimension 10 by 1. So the answer will produce with dimension 2 by 2. At last, we will get the normal equation as shown at above. Next, we must inverse the matrix of M transpose with matrix M. Then we must find the answer for transpose of matrix M and matrix Y. From all the calculation, we can obtain the least square solution by multiplying the inverse of M transpose with M and M transpose with Y. So we are already get the value for A and B. And then we can obtain the best fit linear curve by keying the value of A and B in the maple. So the linear equation is y equal to 958.8667 plus 123.3151x. Next, to find the error vector, the formula is E equal to y subtract with m multiplied with v. So the answer for the magnitude of error vector, which is 2 over 165 square root 158627x65. Lastly, there are two graphs of linear model. At the left side, the graph is graph of best fit curve against its observed data, and the right side is graph of error vector against x values.
Okay, now I will continue for quadratic model. The equation of quadratic model is y equals to a plus bx plus cx squared. And here is the data generates a system of quadratic equations with the matrix representation as below. On the left side, we have a M matrix, and the right side, we have a Y matrix. Okay, next is its normal equation is M transpose M equals to M transpose Y, which is 10, 55, 385, 55, 385, 3025, 385, 3025, and 25,333. For the least square solution is M transpose M inverse times M transpose Y, and we get the best fit in the curve is y equals to 4.8667 plus 175.3151x minus 4.7273x squared. Okay, now the next step is to find the error vector is shown below. The error vector is equals to y minus times v, and we get the 39.5454 until negative 25.2909. And next we must find the error magnitude, and we get a 2 over 15 times 647265. For the graph quadratic model, we have two. For the left side, we have a graph of best fit curve against its observed data with the negative slope. And the right side, we have a graph of error vector against x values.
So next we continue with cubic model. The equation for cubic model is y equals to a plus bx plus cx squared plus dx cubed. The data generates a system of cubic equation with a metric representation is that the left hand side is m and the right hand side is y. mv equals to 1. Its normal equation is m transpose m equals to m transpose y. So the equation is shown below. The least square solution is m transpose m inverse times m transpose y. And the linear curve is y equals to 973.y plus 70.4485x plus 18.0099 x squared minus 1.378x cubed. To find the error vector, we must minus y with mv. So the equation is shown below. The error magnitude is 1 over 715 set 2884110515. Now for the graph cubic model. On the left hand side, we have graph of best fit curve against its observed data, and the right hand side is graph of error vector against x values.
Alright, so for conclusion, based on the table above, it shows that error vector for linear curve is 152.6637.025, error vector for quadratic curve is 107.2703.749, and for cubic curve is 75.110371. Therefore, the best fit curve in this case which will give the best approximation is the cubic best fit curve, because it has minimum error in terms of its magnitude, which is 75.110371. Alright, the graph below shown that this is the cubic graph and error magnitude of the cubic model. So that's all from us. Thank you so much for watching.